Cosmic Abyss, an introduction to black holes. Space is vast and full of wonders. Among the most fascinating objects are black holes. Black holes are regions of space-time where gravity is incredibly strong. Nothing, not even light, can escape their grasp. Imagine a place where the fabric of space and time is distorted beyond recognition. Black holes challenge our understanding of physics and offer a glimpse into the extreme forces at play in our universe. These cosmic entities are not empty voids, instead they are thought to contain an immense amount of matter compressed into an incredibly small space. The study of black holes is a journey into the unknown, pushing the boundaries of human knowledge and imagination. Birth of a monster, the making of a black hole. This is one of the most fascinating and mysterious phenomena in the universe. Stars are the cosmic furnaces that light up the universe, providing the energy and light that sustain life on planets like Earth. But even stars have a lifespan. They are born, they live, and eventually, they die. When massive stars die, they can collapse under their own gravity, forming a black hole, a region where the gravitational pull is so intense that not even light can escape. Imagine a star much more massive than our sun running out of fuel. This depletion marks the beginning of the end for the star. The core collapses, imploding inward at an incredible rate, creating a singularity, a point of infinite density. The outer layers of the star are ejected into space in a brilliant supernova explosion, one of the most powerful events in the universe. What's left behind is a region of extreme density and gravity, a black hole, a cosmic vacuum cleaner that devours everything in its path. The gravitational pull of a black hole is so strong that it warps the fabric of space-time around it, bending light and distorting reality. The more massive the star, the more massive the black hole it leaves behind. These black holes can vary greatly in size and mass. Some black holes are millions or even billions of times the mass of our sun, known as supermassive black holes, residing at the centers of galaxies, including our own Milky Way. Point of no return. Approaching the event horizon. This is one of the most fascinating and terrifying phenomena in the universe. As you approach a black hole, the distortion of space-time becomes more and more extreme. The very fabric of reality is stretched and twisted in unimaginable ways. The point of no return is called the event horizon. It's a boundary beyond which nothing can escape the black hole's gravitational pull. Imagine a boundary in space. This boundary is not a physical surface, but rather a point where escape becomes impossible. Once you cross this boundary, there's no going back. You are irrevocably drawn towards the singularity at the black hole's core. The gravity inside the event horizon is so strong that not even light can escape. This is why black holes appear black. They trap all light within. As you fall closer to the event horizon, time itself begins to slow down for you relative to an outside observer. This phenomenon is known as time dilation. This is due to the intense gravity warping the fabric of space-time. The closer you get, the more pronounced these effects become. To an outside observer, you would appear to slow down as you approach the event horizon, eventually freezing in time at the edge. This creates a surreal visual effect. But from your perspective, you would continue to fall inward, experiencing the effects of the black hole's gravity firsthand. The journey inward is a one-way trip into the unknown. Stretching into oblivion, the phenomenon of spaghettification. What would happen to you if you fell into a black hole? The answer is not pretty. You would experience a process known as spaghettification. Imagine yourself being stretched like spaghetti dough. As you fall into a black hole, the gravity at your feet would be much stronger than at your head. This difference in gravitational pull would stretch your body out into a long, thin strand. The closer you get to the center of the black hole, the more extreme this stretching becomes. Eventually, the tidal forces would become so strong that they would rip you apart, atom by atom. Spaghettification is a consequence of the extreme gravitational gradients near a black hole. Section 5. Beyond the Veil. Speculations and Theories. What happens inside a black hole remains one of the biggest mysteries in astrophysics. Our current understanding of physics breaks down at the singularity. Some theories suggest that you might emerge into another universe or perhaps travel through a wormhole. However, these ideas are highly speculative and not supported by any direct observational evidence. Inside a black hole, the laws of physics as we know them cease to operate. Space and time become so distorted that our current understanding fails to provide a complete picture. The singularity, a point of infinite density at the center of a black hole, remains an enigma, challenging the very foundations of our knowledge about the universe. Section 6. Firewall Paradox, a conundrum at the event horizon. One of the most intriguing puzzles surrounding black holes is the firewall paradox. This paradox arises from the conflict between general relativity and quantum mechanics. General relativity predicts a smooth passage through the event horizon, but quantum mechanics suggests the presence of a firewall of high-energy particles that would incinerate anything crossing it. This paradox highlights the limitations of our current understanding of physics. It suggests that either general relativity or quantum mechanics, or perhaps both, may need to be modified to reconcile the discrepancy. Resolving the firewall paradox could lead to new insights into the nature of gravity, quantum mechanics, and the fundamental laws governing the universe. Section 7. Information Paradox, the mystery of lost information. Another mind-boggling concept related to black holes is the information paradox. According to quantum mechanics, information cannot be destroyed. However, when an object falls into a black hole, it seems like the information about that object is lost forever. This apparent contradiction puzzles physicists. Some theories propose that information is not lost but rather encoded in a subtle way on the event horizon. This idea, known as the holographic principle, suggests that the information content of a three-dimensional object can be encoded on a two-dimensional surface. The information paradox challenges our understanding of both quantum mechanics and black holes, prompting physicists to explore new theoretical frameworks to explain this apparent contradiction. Section 8. Black hole evaporation, the slow fade into nothingness. Contrary to popular belief, black holes are not entirely black. They emit a faint radiation known as Hawking radiation, named after physicist Stephen Hawking, who first proposed its existence. This radiation arises from quantum effects near the event horizon and causes black holes to slowly lose mass over time. The rate of evaporation is incredibly slow, especially for massive black holes. It would take an extraordinarily long time for a black hole to completely evaporate. However, the concept of Hawking radiation has profound implications. It suggests that black holes are not eternal but have a finite lifespan, eventually fading away into nothingness. Section 9. Supermassive giants lurking at the heart of galaxies. Most galaxies, including our own Milky Way, are thought to harbor supermassive black holes at their very centers. These behemoths can have masses millions or even billions of times greater than our Sun. Supermassive black holes are believed to play a crucial role in the evolution of galaxies. Their immense gravity can influence the motion of stars and gas clouds, shaping the structure of galaxies over cosmic timescales. The study of supermassive black holes can provide insights into the processes that drive galaxy formation and evolution. By understanding the relationship between these black holes and their host galaxies, we can gain a deeper understanding of the universe's large-scale structure. Section 10. Black holes and time travel, a dance with relativity. Black holes are often depicted in science fiction as gateways to other dimensions or time travel devices. While these notions remain speculative, the extreme warping of space-time near black holes does raise intriguing possibilities. According to Einstein's theory of general relativity, time slows down in strong gravitational fields. This means that time would pass more slowly near a black hole compared to a distant observer. However, traveling through a black hole to reach another point in time or space presents numerous challenges, including the immense gravitational forces and the potential for spaghettification. While the concept of black hole time travel is fascinating, it remains firmly in the realm of theoretical physics. Section 11. Windows to the universe. The significance of black hole studies. Black holes are not just fascinating objects of scientific curiosity, they are also valuable tools for understanding the universe. These enigmatic entities challenge our perceptions and push the boundaries of what we know. By studying black holes, we can test our understanding of gravity, space-time, and the fundamental laws of physics. They serve as natural laboratories where the extreme conditions allow us to observe phenomena that cannot be replicated on Earth. The extreme conditions near black holes provide a unique laboratory for exploring the limits of our current knowledge. These conditions help scientists to develop new theories and refine existing ones, offering insights into the behavior of matter and energy. Observations of black holes have already led to groundbreaking discoveries. such as the confirmation of Einstein's theory of general relativity. These observations have also provided evidence for the existence of gravitational waves, further expanding our understanding of the universe. As we continue to study black holes, we can expect even more exciting discoveries that will deepen our understanding of the universe and our place within it. The ongoing research promises to unveil new aspects of cosmic evolution and the nature of space and time. Black holes, once considered mysterious and enigmatic, are now recognized as crucial pieces in the grand cosmic puzzle. They help us to piece together the history and future of the cosmos, offering a glimpse into the most extreme environments in the universe.